Welcome to WISE, the Waikato Integrated Scenario Explorer. WISE is an integrated spatial decision support system. This presentation is a short overview of WISE. It provides you with an introduction to the components in WISE, the layout of its user interface, how to set up and run scenarios, the types of results available, and how these can be used to support decision making. As an integrated spatial decision support system, WISE allows you to look out to a wide range of plausible future scenarios. WISE has built in a reference scenario, which is designed to represent a continuation of the status quo, which is based on recent history. Through the user interface, you are able to adjust a wide range of the model's drivers to create any number of what-if scenarios. For example, what if X happened, or what if Y happened? After multiple runs of WISE, you are then able to compare the possible outcomes of your what-if scenarios against the reference scenario, or to compare between different what-if scenarios. This is particularly useful in assessing options and supporting robust decision making. The WISE model integrates together existing environmental, social and economic models such as land use, and then creates dynamic links between these models to form the decision support system. These models operate at different scales within the decision support system, ranging from local to district to regional to New Zealand wide. The graphic user interface for WISE includes a menu bar, the main window, and the land use map window. The menu bar provides buttons to open and save WISE project files. Existing integrated scenarios can also be selected. The reference or baseline scenario is one of these. Any of these scenarios can then be edited and resaved for future use. Further buttons allow you to run the scenarios and to reset them as required. The main window allows users to access and alter the drivers and parameters in individual models. These can be external factors, policy measures, or the parameters of individual models. External factors are divided into economics or population. Economic factors can be altered for each sector in the model, or existing sub-scenarios can be loaded and used. These options also apply to population. For population, fertility and mortality levels can be altered, or net in-migrations can be changed at a district level. Policy measures that can be varied include socioeconomic measures, zoning, and infrastructure. Each of these provides a number of parameters that can be altered by sector or by district within the region. The Parameters button allows you to access the parameters within the individual models within WISE. For example, within the land use model, you are able to access individual land use types and change a number of factors such as accessibility and suitability for that land use. Under the Scenarios tab, you can access existing or create new integrated scenarios by selecting from a range of existing sub-scenarios that have already been created. This allows an ability to build up over time a library of useful sub-scenarios for future use. The Land Use window provides a tool for users to explore different land use layers and to watch the changes in land use as the WISE model runs. Other map windows are also available under the Maps button in the menu bar. This gives you access to a wide range of spatial layers such as infrastructure and hydrology. To recap, the first step is to use the buttons under the drivers and scenarios to set the WISE model up in a way that represents the scenario or the plausible future that you want to model. The second step is to set up the model to capture the indicators that you're interested in. There are a wide range of indicators available under the Indicators bar for social, economic, environmental, and land use. These are automatically collected whenever the model is run. Additional indicators can be captured under the Options tab in the main menu. You are able to write to Excel for specific indicators. You are also able to set up to log maps for a number of spatial indicators and to set the time at which you want these maps to be logged. Also, WISE allows you to set up and capture animated maps of spatial indicators at different resolutions. WISE also has additional tools for the analysis of data. The key one is the Map Comparison Kit. This creates the ability to compare maps between two different time frames or two different scenarios. In this case, we are comparing two different time frames within one scenario and setting it up to look at how daring land use varies between two maps or time steps. What this shows is cells that are the same in both maps are green, i.e. the land use of daring existed in both maps at the beginning and at the end of the scenario. Red is where it only appears in the first map, i.e. the beginning of the scenario, but is not present at the end of the scenario. Blue is where the land use is not present at the beginning in the first map, but is present at the end in the second map. The animated maps produced by WISE are a very powerful communication tool. They show spatially how land use changes throughout the run of a scenario. This is very helpful for people to visualize how a specific land use might change across an area over time. This overview has only shown a brief outline of the results WISE can produce. The strengths of the results from WISE are that it can show spatial changes for a range of indicators. You are able to do a comparison between the indicators over time for a scenario. You are also able to compare how the indicators change between scenarios, and you also set up the model to do sensitivity testing for different parts of the system being modeled. Overall, WISE provides a wide range of indicators in social, environmental and economic areas. Well, this is the end of this tutorial, but please check out the other video tutorials at www.creatingfutures.org.nz. Thank you.